Now,
Good evening, everyone. I'm your host. My name is Antara Ghosh, and I am currently pursuing my bachelor's in forensic science from Parul University. We are very delighted to have you all join us for our webinar series, Future Tech in Forensics, a dive into past. This webinar series is presented in collaboration with the Department of Forensic Science, Applied Sciences, Parul University, and Forensic Talents India. We have already completed 8 successful sessions. We still have 4 more fields to be covered, and we really appreciate your continuous support all the way. Recent advancements in forensic science instrumentation include high resolution mass spectroscopy for precise compound analysis, advanced imaging technique like micro X-ray fluorescence for trace element detection, and portable DNA sequencers for rapid on-site identification. These innovations enhance accuracy, sensitivity, and efficiency in crime scene investigations, aiding in the detection and the analysis of evidence crucial for solving criminal cases. Thus, the various aspects of recently developed instrumentation techniques in forensic science field will be discussed by Shaile Thakur ma'am today. All the participants will be provided with a link in the feedback form in the chat box of the webinar session. On filling the form, they will be given an e-certificate for the proof of participation. If any participant has any queries related to the topic, feel free to ask in the chat box or in the YouTube comment section. The today topic session is Advancements in Instrumentation Techniques by Shaile Thakur ma'am. To invite and introduce the expert, I would like to extend an invitation to Mr. Arun Kumar Kawat, CEO and founder of Forensic Talents India. So,
thank you very much, Antra, for your such a nice introduction. So, our today's speaker is Miss Shaile Thakur. She has completed her BSc in Forensic Science from APJ Abdul Kalam Institute of Forensic Science, Bundelkhand University, Jhansi. She has also completed her Master in Forensic Science from National Forensic Science University, Gandhinagar, Ahmedabad, Gujarat. She is right now working as an assistant professor in Department of Forensic Science in Parul University, Gujarat. She has also previously done assistant professor job in Department of Forensic Science, Vivekananda Global University in Jaipur, Rajasthan. She, ma'am, loves to educate or teaching the students. We are very happy to have you, ma'am, on our platform. Ma'am, it's over to you.
बस चला जाए हेलो
Yes, ma'am. Ma'am, you can share your screen now.
okay hello sir
Yes, ma'am.
good evening
Good evening.
thank you so much for a beautiful introduction and hello students. I'm Shaile Thakur. Sir has already shared my introduction, so I need not to share my introduction. I'm directly going to present my PPT. But yes, first of all, I would like to thank Forensic Talent for providing me such a beautiful opportunity to share my knowledge among the students. And also, I would like to thank Padul University for consistently providing me the opportunity to educate India. Basically, in our university, from all over India, we are having students from different states. So definitely, I'm available for any webinar or any type of guest lecture. Thank you so much, sir. I'm going to share my screen. Just wait for a moment. Is my screen is visible, sir?
Yes, ma'am.
Okay. Just let me know I'm changing, whether it is changing or not.
Sure.
Is it?
Yes, ma'am.
Okay,
You
fine.
can start the presentation view, ma'am. So slideshow.
Yeah. Yeah. Okay. So I'm going to discuss about advancement in instrumental technique. So, see, everyone knows the importance and value of instrument in the field of forensic science. Yes, I'm not going to directly jump in the field of instrumental technique. First, let me correlate the forensic science with instrument. You all know what is forensic science, what is the definition of forensic science, why forensic science is required for for our society, why this field is mandatory for the society, we all know very well, right? And I hope that all students are related to forensic field only. Okay, so basically, in forensic science, we are dealing with the investigation, right? And we are aiding to law enforcement agencies, right? We are helping the law enforcement agencies. Now, how we are helping, right? So we are helping basically to solve crime. Now, how we are solving the crime? By the help of the evidence. Now, of course, you all know that evidences are available in different form, either in physical form or digital form. So, when we are having the evidence in physical form, that time this instrument plays a vital role, even I will say an essential role to provide you the exact data, to help you to investigate your evidence, right? So, therefore, the instrument is very, very important component of forensic science, I must say, right? Because whenever we are producing any report, whenever we are doing the investigation of the evidence, so that time you all know we need to do two type of investigation. One is your preliminary, another one is your secondary, or you can say the confirmatory, right? So we in the very beginning of the course, like your bachelor's, you must study about the preliminary test and confirmatory test, right? So all the preliminary tests associated with the primary type of test, right? So when we are talking about the primary type of examination, so that time either we are doing the color test or any physical test, or we can say any order test, right? So these are the simple tests which helps us to give the path, or which help us to show the path, right? So basically this type of tests are very, very essential in the field of forensic science for the investigation purpose, right? Once we are done with the preliminary test, so we need to go for the confirmatory examination or the secondary examination, because on the basis of preliminary test, we are not supposed to submit the data in the court of law. Otherwise, the court is not going to accept your data. Therefore, you need to present the secondary, or you can say the confirmatory examination, right? In the form of report, right? So, after preliminary examination, we need to go for the confirmatory test. And confirmatory test must be, most of the time it must be done by some chemical analysis, but many of the time it is done by the instrumental technique, right? Suppose if you have done the TLC of any drug, of any ink, but after that, you need to go for the confirmatory examination. Confirmatory examination means involvement of the instrumental technique, which gives us the result. And those results we can produce in the form of data or report and submit it to the court of law, right? So therefore, with the advancement of the era, right, there must be the advancement of the instruments, right? And our instrument in forensic science are getting advanced day by day, right? If you look into the history of the forensic science, right? So look into the past history of the forensic science. So earlier we were facing lots of challenges in creating or reconstructing the forensic science, but nowadays we are having the special gadget, right, that is known as 3D scanner, which help you to reconstruct the crime scene without involvement of much people, right? So basically, the person sitting in the Delhi can access the crime scene of the other place, right? So you why I am discussing this point, although my topic is different, my topic is related to the spectroscopy. My main topic is advancement in instrumental technique. Therefore, uh, I am just discussing this few gist point or bullet point orally, just to introduce you people with instrumental technique and the importance of instrumental technique, because it's not possible to add everything in the slide. And if students demand for the slide, I will send the slide to sir, and sir will share my slide to the students also. Okay, so I was on 3D scanner. Okay, so earlier it was very difficult task to do the reconstruction of the crime scene, especially to those places where there will be the removal of the evidences, tampering of the evidences, right? But nowadays we are having the awesome option of the 3D scanner, which are having the different type of light, which can scan the length, breadth, height of the evidence, of the trace evidence, which are present in the small amount on the scene of occurrence, and give you the result and the data in 3D form. And after that, you can go with the proper analysis, right? But earlier we were facing a lot of challenges. Few people were doing the sketching, few people were doing the photography, few people were doing the videography, few people were making notes. But these problems already, this problem and limitation was overcome, and the 3D scanner is playing essential role in the field of the entire forensic science, especially for the reconstruction of the crime scene. Okay, now without wasting time, I would like to move towards the topic, right? So my topic is diverse advanced technique in spectroscopy, right? So I hope you all must know what is a spectroscopy, right? So spectroscopy is one of the most important branch of science, or the most important field of science, to study the interaction of the matter with the light, right? So whenever our matter means sample, right? So whenever our sample, our matter is getting interacted with the light, so three or two things happens. Either the absorption of light takes place, either the transmission of the light takes place, or the scattering of the light takes place. Based upon this phenomena, we are having different types of spectroscopy. Okay, so spectroscopy is the most important branch of science, and yes, spectroscopy plays very important role in the field of investigation, right? So therefore, the spectroscopy is, the most important part of our syllabus also. Okay, now what do you mean by the EMR, that is electromagnetic radiation? Okay, so you all have heard in class 12, right? Your physics teacher must taught you about EMR. What is EMR? Basically, the EMR is your electromagnetic radiation, which consists of different electromagnetic field, right, which are basically propagating through the space, right, through the and carrying the magnetic radiant energy, right? So it includes your radio waves, UV, IR, visible, gamma, etc. Right? So all of these are the part of your electromagnetic radiation. Okay. Now, what do you understand by the term spectrometer? See, spectroscopy is the branch of science, right, with the investigation and basically the measurement of the spectra whenever it interact with the matter. So basically, spectroscopy is the study. We always used to say what is microscopy. So microscopy is a study. So whenever the term scope is attached, so it means study, right? But whenever we are talking about a spectrometer, so what do you mean by the term spectrometer? Spectrometer basically is an apparatus or instrument used for recording the spectrum or interpreting the spectrum, right? So basically the instrument is known as a spectrometer. So this is very, very important to understand. Okay. So this is our types of spectroscopy. I have already discussed UV visible, IR, ATR, FTIR, X-ray, AAS, AES, FIS, FEM, NMR, right? So we are having ample number of spectroscopy with a lots of advancement. We will discuss about the advancement, right? And also discuss about the few types of spectroscopy, although I am having only 1 hour or 45 minutes, right? So within 45 minutes or 1 hour, I need to compile all of the topic. But yes, I'll try to compile or cover most of the topic within my prescribed time. Okay. So basically, you all have heard about UV visible spectroscopy, right? So whenever we are talking about UV visible spectroscopy, so see the name is entitled only UV visible. That means we all are dealing with UV visible light. So whenever the ultraviolet light come in contact with the sample, there must be the absorption of the light because of the concentration present in the sample and few lights get transmitted, right? So the UV spectroscopy is based upon the Beers-Lambert's law. I'm not going in detail, right? But I'm just giving the overview of UV spectroscopy. So it is based on the Beers-Lambert's law, and basically it gives you the qualitative and quantitative analysis, right? Uh, Okay, so it gives you the qualitative and quantitative analysis. So when we are talking about the, see, when you will study about instrument, right? When you will deal with the spectroscopy, you always heard about qualitative and quantitative analysis. So qualitative analysis means whenever you come to know about what type of component present in the sample, that is qualitative analysis. That means it tells you the quality of the sample. Whenever we are talking about the quantitative, that means it is telling you the concentration or how much. Suppose there is a compound A, and in compound A, you are having XYZ sample, right? So uh, how much X amount is present in the sample? How much Y amount is present in the sample? And what is the amount of Z present in your A sample? So basically, the quantity is dealing with the concentration of the component present in the sample. So this is about qualitative and quantitative analysis. So you all know UV visible based upon Beers-Lambert's law give you qualitative and quantitative analysis. And in this, we can analyze most of the compound, and basically the UV visible spectroscopy plays a vital role in the field of forensic chemistry, forensic toxicology, etc. Okay, now coming to the IR. Why I am going to focus a little bit about IR? Because see, we are in the stage where we have developed from basic IR to advanced IR. So in advanced IR, we are having two type of advanced IR. One is FTIR and another one is ATR FTIR, right? So we will discuss a little about IR. Then we will move to FTIR, and after that ATR plus FTI. So when we are talking about the IR, so IR, see, IR is a electromagnetic radiation itself, which having the wavelength up to 780 nanometer to 1 millimeter, right? So this is the wavelength of the IR radiation. Okay, this is the wavelength of the IR radiation, that is from 780 nanometer to 1 millimeter. This is the wavelength. Okay. When we know the wavelength, when we know what type of radiation it is. So if I ask you what is IR spectroscopy, so of course that study will based upon the interaction of matter with IR radiation, with IR range only, right? So this study is basically deal with when your sample interact with the IR radiation. It's known as your IR spectroscopy. The study is known as the IR spectroscopy, and it is, very powerful technique, I can say, because it utilizes the natural sources of IR radiation, because the natural source of IR radiation is sun. So basically, this is most powerful natural source of IR radiation is sun, right? So this can help us in different fields, not only in forensic field, but in the biochemistry, biomedical, forensic science, another field of the science, right? So IR is extended to every science field, right? And IR play a very important role in the field of the forensic science also, right? So basically, the IR study, as I discussed, is study of the IR from the electromagnetic region and when it is interacting with the matter, right? So basically, when IR interact with the matter, so what happened inside the matter, right? So two important phenomena occurred in the matter. One is either the vibrational transition, and another one is the basically the rotational movement, right? So this is very important element, right? And this is very important to understand when your light meets or interact with the sample. So the light is providing the energy to the sample. So your sample is grabbing or absorbing that energy. So when the sample is absorbing that energy, so sample contains, of course, the atoms. And atoms is surrounded by the electron. And in the middle, that is the nucleus, contains the proton, right? So whenever the light is getting interacted or energy is getting interacted with the sample which contains the electron will definitely shows the electronic transition. Because of those transition, we are analyzing our sample. So basically what happened in IR, so in IR, we are whenever the sample is interacting with the IR, so two phenomena occur. One is your basically vibrational transition, another one is your rotational, right? So these two type of phenomena occur in the IR, right? So we need to measure basically three things in IR. One is the reflection, another one is the emission, and one is the absorption, right? So you all know what is reflection, emission, and absorption, that I am not going to discuss. But what is the another name of IR? This is important for your competitive exam. So the another name of IR is vibrational spectroscopy, or it is also known as fundamental vibration. It's also known as vibrational rotational spectroscopy. Okay. So this is the important terminology which is associated with the IR. I haven't added this slide as I told you that it is not possible to add a lot of slide in one PPT, right? So I'm discussing everything orally, okay? So if any student faces any problem, you can ask me or you can, or sir can contact me for the PPT, okay? So we are having three types of IR range, basically your near, mid, and far. Okay, and yes, the the principle of IR is related to vibrational and rotational energy of the molecule. Okay, so this is the principle of IR. Therefore, IR is known as vibrational rotational spectroscopy. Okay, so this is this is I'm talking about the basic of IR. Okay, so whenever we are talking about the basic of IR, we must little bit focus on the theory of the IR, right? So whenever we are discussing about the theory of the IR, okay, so there must be few criteria. The compound, or we can say the uh, compound or your sample must meet these few criteria, which is it must have the property to shows the change in the dipole moment, like your HCl. H is positive, Cl is negative. So there is a change in the dipole moment. So this is the most important criteria for your IR, right? Then the correct wavelength of the radiation, okay? And this must have the IR active property, right? So IR can detect only IR active molecules, right? So basically, whenever your sample, right, your sample is interacting, suppose this is your sample, and suppose this one is producing the light, okay, this one is the light source, this is your sample, okay. So whenever this light interact with this sample, this one is the sample, whenever this light interact with the sample, so what happened when the sample contains, of course, atom, and whenever those atoms are absorbing the light, so few changes occur in those atoms, and the changes are stretching vibration. So basically, the stretching vibration means the stretching among the bond, right? So these stretching vibration are of two types, symmetrical and asymmetrical, right? So when we are talking about the symmetrical, means your this is your suppose central atom, and from central atom the stretching occurs equally in both the direction. That is your symmetrical stretching. Okay, when we are talking about asymmetrical stretching, so the stretching of the bond occurs in the opposite direction. Your central atom is remaining on the same position, but the stretching of one atom occur in this direction, and the stretching of another atom occurs in the another direction, right? And what type of stretching is occurring? Stretching of bond is taking place. Okay. Then coming to the bending vibration. So whenever we are talking about the bending vibration, so bending is of four type. One is your scissoring. Okay. So always keep in mind while studying all this stuff, we need to fix the central atom, and apart from central atom, the two other atoms are showing the changes, right? So what happened in scissoring? Like the movement of the scissor, your central atom is fixed and your other two atom is coming like this. Okay, this is your scissoring in the same direction. Then the rocking, in rocking, the what happened? The bending takes place in again in same direction. In same direction, scissoring, in scissoring, it is takes place in opposite direction. I'm so sorry. What happened? One atom will go this side, another atom will go this side. So this is basically the opposite direction. When we are talking about the rocking, in rocking, the central atom is of course remaining fixed in everything, and the two atom is moving like this, okay, in one direction, okay. And whenever we are talking about the twisting. So suppose you are drawing a x-axis. So your one atom is above the x-axis, another atom is below the x-axis. Okay. So this is your twisting, means two atom in the opposite direction, right? That is out of the plane. Okay. And wagging means two atoms with respect to the central atom coming forward, going backward, coming forward, going backward. Okay. So this is wagging, and these twisting and wagging come in the out of plane, and scissoring rocking come in the in plane, right? So this is about the bending vibration, stretching vibration. So let's talk about the conventional IR little, so that we can understand the value of FTIR and ATR. So basically, the conventional IR, in which we need to prepare the sample, we need to go for the sample preparation, we need to go for the pallets preparation, right? In conventional IR also, we were utilizing some good points, but apart from that, we were dealing with the destructive sample preparation, in which after the sample subjected to the IR instrument, we were unable to reuse the sample, right? So this is a quite challenge in the forensic science to develop the non-destructive technique. See, because I'm not saying it is easy to develop destructive technique, but see, destruction is easier, but to keep sample as it is, or to make it avail in the form of reuse, we need to develop the technique which are more acceptable by forensic society, that is non-destructive technique. So FTIR, ATR is of course not destructive in nature, right? So in conventional IR, we need to prepare the sample, we need to go for the sample preparation. Why? Because to meet the criteria, then to convert the state of the sample, right? You cannot directly put the sample in the IR instrument. Your IR instrument is not going to analyze your sample. So to make your sample analyzed, we need to go for the sample preparation. For the solid sample, we need to prepare your mull technique, or what is mull technique? Sample is mixed with the mulling agent, and then after mixing, you need to convert it in the paste and then put it in your palette, right? And after putting on the palette, you need to subject in the IR instrument, right? So this is your mull technique. Now, after mull technique, the another method was solid in solution. You need to mix the solid with the solution, right? You need to prepare the KBR palettes in conventional IR, right? Palette preparation was quite challenging because you need to prepare the same shape and size of the palette, right? Then the case film technique, these were press palette methods, these were so challenging, right? And also takes a lot of time, although it gives you the data. I'm not saying it will not give you the data, it will definitely give you the data. But apart from that, it is quite challenging. Why it is challenging? Because you need to meet with sample loss, sample destruction. Once you will subject your sample in the IR instrument, you are to reuse it, right? So to meet these challenges, to overcome with these challenges, the scientists develop the different modern form of IR. So the most important form of IR is, or the most first modern form of IR is FTIR. So FTIR is basically your most important and modernized form of your IR. Okay, so your FTIR is basically stands for your Fourier transform infrared spectroscopy, right? So Fourier transforms infrared spectroscopy. In this, we need to prepare sample, but the steps are minimum. The time consumption is minimum, right? And the detector we are using in FTIR are quite enhanced or sensitive, we can say, and very fast. Okay, so this takes less time than your conventional IR. So, of course, it contains the interferometer, right? Because of which your analysis is very, very simple. Okay. And this is very, very important that this FTIR is based upon the Michelson interferometer, which contains the beam splitter, moving mirrors, and the fixed mirror, right? Because of this, we are, using this instrument in a very wide manner. Even we are having this FTIR in our Padul lab also. But there is one more advanced technique, that is ATR FTIR, right? So ATR FTIR is the very, very important technique of your IR spectroscopy, that is attenuated total reflectance. So you all have studied about the total reflection, right? Total reflection phenomena, right? So this ATR FTIR is the type of the magical instrument in which you did not to go for the sample preparation in max of the time, right? Because if you put the sample directly on the stage of the instrument, the stage is made up of diamond. Because of that diamond, it shows the attenuated total reflectance property, which gives the history of the sample, right? So there is no need of the sample preparation in ATR, FTIR. There is no need of the KBR plate preparation most of the times, right? So this is very, very, very important, okay, to know that we are having such facility. Although the although the yes, so the FTIR is the most advanced technique of the ATR FTIR is the most advanced technique of the IR spectroscopy. Although the entire technique is based upon the same principle of IR. We have studied about the IR principle, right? Based upon the vibration and rotation. This is also based upon the vibration and rotation. Only we have change in the mechanism, not in the principle. The principle is same. The mechanism are same, but we have introduced some important part, right? So this is why this technique has become very, very advanced technique, right? So this is the basic point I have written about the FTIR ATR that I have already discussed, right? Okay. Now coming to the little bit about X-ray spectroscopy, right? So X-ray spectroscopy is one of the very, very important field in the spectroscopy. We have covered two spectroscopy, that is your UV and IR. And then third one is your X-ray spectroscopy. So X-ray spectroscopy is again very, very important, in which we are using the X-ray field of the or X-ray range of the electromagnetic radiation. Okay, X-ray range is very, very important in the X-ray spectroscopy, as we are using the X-ray range of EMR. Therefore, it is known as X-ray spectroscopy. What is the use of X-ray? You people must visit the place where, or you people must visit to doctor where your doctor has advised you to go for the X-ray, right, of your bones. So basically, the X-ray give us the internal view of anything. So whenever the doctor is suggesting you to go for the X-ray examination, that means the doctor want you to go for the internal examination of your body or your bone, right? So the X-ray having the capacity to give you the internal view of anything. So you can understand that if we are using the X-ray spectroscopy, so we are getting the internal view of our sample. Okay, it will also give you the qualitative and the quantitative analysis. Okay, so basically, the X-ray was discovered by William Röntgen, right? So what he did the experiment. What type of experiment it was? Basically, there was a tube in which the low pressure gas was filled. So when the electric current was passed through that low pressure filled gap, there was the production of special type of the ray, and that ray was named as the X-ray, right? So whenever your X-ray interact with the sample, three phenomenon occurs basically. One is your diffraction, another one is your transmitted radiation, and the third one is your fluorescence radiation. Okay, so we will definitely discuss one by one. If it is not possible today, I must request sir to provide me one more session, right? So definitely I will like to talk more about the spectroscopy. Okay, so uh, basically the diffraction. You all have heard about the word diffraction. So what is the literary meaning of the diffraction? So whenever you are passing light on any surface having the irregular surface, so the light will go from means it will not spread evenly, it will spread unevenly, right? So that is diffraction. Then transmittance means whenever it is getting transmitted. Fluorescence. We'll discuss about the fluorescence because it is a phenomena. Okay, this is the use of the X-ray application in different fields, like you're in material science, biology, meteorites and the space science, cultural heritage, solid state physics, geophysics, mineralogy, right? Chemistry, forensic science. In forensic science, sir, means we must have encountered many times about XRD of GSR, XRD of this, XRD of this. So all depends upon, all based upon the X-ray principle only. In every XRD, we are using X-ray only, right? So X-ray spectroscopy is very important, in which we have to discuss all these three important type of spectroscopy, right? So basically XRD, these methods are based on the scattering of X-ray by the crystal, and this give you the structure, right, of any solid compound, right, with a high degree of the specificity, means it is highly specific, okay? And XRD is extremely important as compared to other X-ray spectroscopy techniques because XRD give you the crystal structure of any solid compound. Okay. Then coming to the X-ray absorption. So absorption is it is same as the absorption spectroscopy, right? So whenever your sample is absorbing the light, there must be the electronic transition in the electrons, right? And because of those electronic transition, we are measuring the concentration of the component present in the sample, right? So this is about your X-ray absorption. So what happened? It gives the information about absorbing material. More the concentration, more will be the absorption, right? So Beer's law: more the absorption, more the concentration, more will be the absorption, right? Because the higher concentration, higher the amount of element present in your sample, higher will be the absorption of the light. So it gives you about the information about the absorption of the material. Then another important thing is, in this method, beam of X-ray is passes to the sample, right? And whenever it meet your sample, right? Whenever it meet your sample, the fraction of the X-ray photon absorbed, and it helps you to find out the concentration of the sample, right? This method is very important as compared to other X-ray methods, and also give you the external structure, right? Basically give you the elemental analysis. When we want to go for the elemental analysis, thickness measurement, we are always opt this X-ray absorption, right? So this is the basic instrument. This is the light source, right? In the cuvette, your sample is present. Cuvette is your sample holder, and with it, the detector is attached. This is a simple phenomena to make you understand. This is how the light passes, and the sample present in the cuvette interact with the light. And some light get absorbed, some light get transmitted, and we are getting the result on the detector and readout device, and then we interpret the data. Okay, fine. Then coming to the X-ray fluorescence or X-ray fluorescence spectroscopy. Now, in this, the X-ray are generated within the sample, right? And by measuring wavelength intensity generated by X-ray, we can perform the qualitative and quantitative analysis, right? And this type of instrument are, trust me, non-destructive in nature. Okay. So, this is a simple diagram, right? You all have studied in your basic class 12 that whenever one electron jump from its higher state to lower state, right? What happened? There is a creation of the vacant cell, and that vacant cell need electron to become stable. So another electron come and jump in that vacant cell, and the same time there is the release of energy, and those are the fluorescence radiation or secondary X-ray. Okay. So basically, this is the production of X-ray. So in the lab, the X-rays are produced. So X-ray can be produced by the two methods. One, with a high velocity electron knock out the other electron, right? When your high velocity electron of your own atom knock out the electron of the same atom, right? And another one is high velocity electron will strike the anode material. I hope you all know about anode cathode material, right? So when high velocity electron will strike the anode material in a discharge tube, which result in the production of the X-ray. This is very, very important phenomena, right? And this is how the production of the X-ray takes place. In every X-ray spectroscopy, we are having this instrument, right? The instrumentation are X-ray generating equipment. Of course, in X-ray spectroscopy, we are having the X-ray generating equipment which generate X-ray, okay? And because of the generation of the X-ray, of course, your X-ray will come and interact with the sample, right? Then there will be the collimating lens or the collimator, and another one is your monochromator. So basically, the collimator lens and monochromator will select the single wavelength or the particular filtered wavelength of the light and allow it to pass further. And then last but not the least, the detectors. So detectors are basically the sensitive or heart of the spectroscopy. So detector give you the final result in the form of the spectra, and that spectra you need to analyze or interpret. So here we are using Giger-Muller counter detector, scintillation detector, solid state semiconductor detector, semiconductor detector. These are the different type of the detector. I forget to discuss about the photographic plate. Actually, we are having two type of detector. One is your photographic method, another one is your counter method. In counter method, we are having the Giger-Muller detector and semiconductor scintillation and solid state semiconductor detector. In the method, basically there is a film on which we are getting the sample value, right? So basically we are getting the result in the form of film. So this is the photographic method. Okay. So the forensic application of X-ray is identification of the chemical species, analysis of metals, contaminants, right? Then in case of forensic anthropology, of course, right? Then art of the forensics geochemistry. Okay. So these are the basic of your X-ray spectroscopy along with the forensic principle, right? Now, I'm going to little bit discuss about X-ray fluorescence spectroscopy. Okay, so basically, I have discussed about how fluorescent light is produced. So basically, this is the basic atomic structure. Suppose your one electron get jump, or suppose your one electron vacant the existing cell. So to fulfill it, another electron will come and jump into the cell. This is how there is the transition and produce the secondary X-ray that is known as fluorescent X-ray, right? So basically this technique utilizes the interaction of X-ray with the material to determine the elemental composition. In short, this X-ray fluorescence spectroscopy, also known as XRF, right? So whenever you heard about XRF, do not get confused. This is nothing but X-ray fluorescence spectroscopy. And yes, the beauty of this instrument is to detect your sample in ppm level. Can you imagine the ppm level is a very, very, very small parts per million level, right? That is a very, very low amount of the sample it can analyze. Then think how sensitive is this instrument, okay? Then this is the instrumentation. The basically there is a X-ray source which produce the fluorescent light, and whenever these X-ray means secondary X-ray is produced and made with the sample, right? So there is must be the absorption and transmission of the light. Based upon that, the detector will detect, and then it goes to the amplifier, and after the amplifier it goes to the digital pulse processor, and ultimately to the computer. Computer will show us the spectra, right? So spectra are produced on readout device. Okay, forensic application is same, trace evidence analysis, and then the most important is in your ink analysis, GSR analysis, toxicology analysis, environmental forensic in the field of environmental forensics also, right? Suppose the mercury, lead, heavy metal present in water, which is affecting the environmental factor. So this is very, very important. Then art, culture, heritage, etc. Everywhere the XRF is, of course, the omnipresent instrument. Okay, XRD I have already discussed, right? XRD is very, very important, and XRD is based upon constructive and destructive interference. Okay, when I get time, so I will definitely discuss all the detail of XRD, beautiful instrument, right? Basically used for the GSR. This is the main instrument in your elemental analysis, right? And it contains the following component: radiation source, collimator, monochromator, sample handling detector, then detector. Okay. And the application of XRD is identification of cause of the unknown sample, drug analysis, explosive analysis, trace evidence analysis, right? Then archaeological forensic, of course, in forensic, environmental forensic to analyze the heavy metals, right? Then your firearm analysis. One of the beautiful instrument is Auger emission spectroscopy. Yes, you all have heard about the Auger electron, right? So Auger electrons emission spectroscopy, as it depends upon the Auger electron, the name has been assigned as Auger emission spectroscopy, right? So you all have heard about Auger electron in your previous school days or your previous classes. Okay, so Auger electron basically is your type of electron, which is when your atom contain the electron, right? The periphery, right? And nucleus in the center. Okay, so suppose you are having the atom in which you are having the nucleus, and in the periphery you are having the electron which are rotating. So basically we are having KLM shell, right? So when the high energy photons, right, come and interact with your atom, right? So basically what it does, it penetrates the atom and reaches to the electronic orbital of the atom, right? Let's say your photon is coming to the K shell, okay? And suppose K shell electron, your photon is interacting with the K shell electron directly, right? And which result in the emission of the K shell electron. Means your K shell electron get knocked out. So whenever your K shell electron get knocked out, so what happened? It create the vacancy here. So you cannot leave the vacant place, otherwise your atom become unstable. So after creation of vacancy, the atom become, of course, unstable. So to make your atom stable, the electron from the higher cell, let's say the L cell, will jump and fill the K shell. Okay, that vacant part is filled by your L shell electron. Okay, and whenever the energy difference between K shell and L shell appear. Okay, so what happened? It appears basically it appears as your uh, transition. Okay, so there is a difference in K cell and M cell, L cell, which appeared as a transition known as the characteristics X-ray. Okay, and whenever the Whenever, instead of going outside, the characteristic X-ray will absorb by the orbital electrons, right? The characteristics are not going outside and absorbed by the orbital electrons. So what happened? Let's say it is absorbed by the M shell, right? So after the absorption, what happened? The electron from the M shell get ejected, right? Because see, the characteristic X-ray also having the energy. So these energies interacting with again the another shell of the atom. So M shell is going to release its electron, and after the absorption, what happened? And there is a ejection of the electron. These ejected electron are known as Auger electron, and the entire process is known as Auger effect. So based on this effect and based on this Auger electron, the scientist has designed the auger electron spectroscopy, which is very, very, very important, right? So in 1923, the most important technique was introduced, right? So the name was, and still the name is auger electron spectroscopy, but nowadays it is present in the very, very advanced form, right? So it can also detect the ppm level of the sample. Now, what are the instrumentation? The instrumentation are UHV, that is your ultra high vacuum environment, electron gun, electron energy analyzer, and electron detector. This is how the mechanism, working mechanism looks like, right? There is a sample present, then there is a secondary electron detectors present, right? Then in above that, we are having the cylindrical mirror analyzer, then field emission electron gun, right? So this is very, very important part of your AES, that is auger electron spectroscopy, right? And what is the forensic application? Forensic application is in the field of the ballistics, in the field of the paint chips, I mean, in the field of the forensic chemistry, forensic toxicology, right? We can also analyze the paint chips or the element present in the paint, right? Or your, we can say the vehicle present in the paint can be analyzed by the auger electron spectroscopy. And this is very, very, very sensitive instrument, right? So whenever you people get chance to do your internship by the use of different instrument, you must try to participate in such instrument because it will develop your skill. See, I cannot say that you will once you will do the internship, you will know 100% about the instrument, because see, the software is keep getting updated, the software is keep changing, right, by time. But you should know the basic theory, basic working mechanism, basic structure of the instrument, basic component which are used in the instrument, right? Because these things will remain same. Only there is the advancement or addition in the software or addition in the few parts which make the instrument modified, right? But we should know the basic about the instrument, right? So, this is very, very important. Whenever you are in the field of forensic science, you must focus on instrumental technique. This is very important, right? And thank you so much, sir, for providing me the opportunity. I always love to work with you. I always open for such webinar in my future also. Thank you so much.
Thank you very much, ma'am, for your such a good and very interesting session. There are some questions from our participants, ma'am. So first is, how are forensic scientists using scanning electron microscopy with energy dispersive X-ray spectroscopy to analyze physical evidences?
Scanning electron microscopy, right? So see, we are having SEM-TEM, right? And the SEM-TEM is the most important. Visible?
Yes.
Hello. Okay. So STEM-10 is the most important element of the forensic science, and it will also give you the, we can say, the internal view of any sample as well as the 2D view of the sample, right? Both 3D view and 2D view you will get with the help of the SEM, scanning electron microscope. Right? So this is how it play a very, very important and vital role in the field of forensic science.
Okay. Next question is, what role do microfluid devices play in modern forensic science instrumentation, and how do they enhance forensic analysis process?
Hello,
Hello?
hello. Am I audible? Actually,
Yes,
your
ma'am.
voice is cutting, therefore I'm not getting you.
Okay. So the ma'am question is, what role do microfluidic devices play in modern forensic science instrumentation, and how do they enhance forensic analysis process?
Sir, I'm not able to. Can you please check your microphone because my microphone is working because it is
Uh,
now connecting.
just a second, ma'am. Am I audible, ma'am?
Hello.
Hi, yes, ma'am. Am I audible?
Yes, and now you're audible. Please repeat your question. Actually, still your voice is breaking, but please, when I was presenting, is my presentation was properly visible to all the
Yes,
students?
yes, yes, ma'am.
Okay, it was. Okay, fine, sir. Please let me know.
Okay.
Actually, there is a, you know,
No issue,
I'm
ma'am.
using tell
No
me.
problem, ma'am. So the question is, what role do microfluidic devices play in modern forensic science instrumentation, and how do they enhance forensic analysis process?
Okay, so basically, microfluid device plays a very, very significant role in the field of forensic science, basically in DNA analysis, right? In toxicological analysis, trace evidences analysis, then microbial forensic analysis. So basically, our microfluid device has a very significant role in the forensic science due to the ability to manipulate the small volume of the fluid to the high precise precision and automation, right? So this is how it is very, very useful.
Okay. So next question is, how are mass spectroscopy techniques utilized in forensic investigation, particularly in identification of unknown substance?
Yes, sir. So mass spectroscopy means we all know that what it do, it basically uh, has the property to disintegrate the ion into the daughter ion, right? So it give you the identification, quantification, characterization of the various component in forensic sample, right? So basically, whenever we are adding or we are what we say, we are in addition of mass spectroscopy with GC, right? Or when we are attaching the mass spectroscopy with any instrument, then it acts as the detector, right? So it is useful for the drug analysis, explosive detection, in the field of the toxicological analysis, in toxin, poison, metabolites, in the basically biological specimen, right? Or the fire debris analysis. So nowadays we are attaching the MSMS, tandem MS with GC, gas chromatography, mass spectroscopy, right? So it gives you the very precise and specific result.
Okay. So next question is, ma'am, what advancements have been made in instrumentation techniques for DNA analysis in forensic science?
Sequencer, sequencer is very, very advanced. Means we are having the PCR to multiply our the sample to DNA, and we are having the sequencer for the sequencing. So we are having a lot of advanced technique in the field of forensic DNA.
Okay. So, ma'am, the next question is, what are the benefits of using X-ray fluorescence spectroscopy in forensic analysis, and in what scenarios it is particularly useful?
Basically, in case of low level of the sample, we are using XRF, you are asking, right?
Yes, ma'am.
Okay, so XRF is used in the basically where we are having the sample present in the ppm level, and when you are and the another one is if your sample is having the fluorescent property, and if it do not have the fluorescent property, uh, we can add some specific fluorophores to make it, or to make it like the property of the fluorescent. So basically, it used in the case of your forensic explosive, in the case of explosive investigation, GSR analysis, etc.
Okay. So, ma'am, that's it from our audience. Thank you very much, ma'am, for your presentation and your answers for the participants. Thank you very much, ma'am.
Thank you, sir. May I
Okay.
leave, sir?
Yes, sir. Yes, ma'am. Sure. So, dear participant, our next webinar is on 9th April 2024 by Hitarthi Trivedi, and her topic is Advancement in Tools Used in Digital Forensics. The link for the same will be shared on your registered email ID. Thank you very much, everyone.
Thank you,